pleasure to be here. I'll be discussing the paper by Michael Darden. Can everybody hear me? Yes? So basically, this is about cognitive decline and dynamic selection. I'm at the Center for Economic and Social Research, so this morning my commute was from the 5th floor to this floor. Okay, so the topic is cognitive decline and dynamic selection. So say that you wanted to understand the effect of education on cognition or the effect of smoking on cognition, then you need to take into account dynamic selection. Smoking may lead to selection. The poor, the basically people in the poorest health may select out of your sample. So that's what this is fundamentally about, that your sample starts changing, and so that it becomes, that there are all kinds of biases as a result of this. Oh, sorry. Okay. So here then some of the motivations. So Alzheimer's disease is the most common type of dementia. This is not really Alzheimer's though, but it's related. It's about cognitive decline. So dementia is important, we know. I mean, it's the 7th most common cause of death. Some 6 million Americans live with Alzheimer's disease, and it's also projected to nearly triple. So a lot of concerns about cognitive decline. Cognitive decline also has important implications for economic productivity, quality of life, retirement planning, etc. So this stuff is important. Here we see a picture of Alzheimer's disease. We see a healthy brain on the left-hand side and severe Alzheimer's on the right-hand side. Yeah, basically cognitive decline. There's a framework of that's called cognitive reserve theory. That basically the idea is that investments, so things like education, cognitively challenging occupations, healthy lifestyles, etc., that they can build a reserve that buffers against age-related pathology. So for given brain pathologies, the hypothesis basically that there exists still variation in past cognitive abilities. So it's this idea that of resiliency that's produced over a lifetime by avoiding risky behaviors such as cigarette smoking, excessive alcohol use, physical exercise, etc. And the most important thing for now is that it also suggests complementarities between physical and cognitive health. Then here we see a graph of cognitive differences by education from Darden's paper. It shows on the y-axis basically the sum of word recall. This is immediate word recall and delayed word recall, and basically it's 10 words for both items. It's summed up so that it runs from 0 to 20. We see basically these differences between here less than high school, and here we have high school graduates, and then here we have college graduates. So the idea of resiliency is that higher levels of education kind of give you this kind of more cognitive reserve, because you have more exposure to using your brain, etc. And so it's protective. Now the question here is all about whether these kind of slopes make sense. The idea of resiliency is that there is a kind of a level effect. The cognitive reserve hypothesis has been, as I understand from the paper, basically is based on the fact that these that they run relatively parallel. So the question here is, do they in reality, basically, and that's what we're going to discuss. So cognitive reserve theory is also, as Michael notices, is very similar to a large literature in economics that's on the production of health. I'm citing myself here because actually Michael Darden did this, but I guess my claim to fame for this paper is that I wrote a paper on the Grossman model. That's, no, exactly. So that's this one with Hans van Kippersluis, where we extended the Grossman model. And I think one important contribution of it is that we dropped the linearity assumption, because that leads to a degeneracy. So, so empirical insights in this paper basically, the paper claims that empirical insights that results from connecting economic theory to data have yet to be applied to cognitive decline, and the idea is that you can use a Grossman type model. So what the paper then does is it formulates and estimates a model of health, of behavior, cognitive and general health, and also mortality. And it highlights two empirical challenges in identifying determinants that shape the age profile of cognition. The first challenge is that the potential determinants are endogenous. If you look at cross-sectional comparisons of cognitive health by education, they will likely overstate the importance of education because high ability individuals sort into higher education and also perform better on cognitive tests. So if you look at higher educated individuals, then you might, and there's this correlation with cognition, you might attribute these higher cognitive tests to the levels of education, but it reflects sorting. So that is what Michael Darden calls endogeneity bias, and that is the first challenge. The second challenge is then competing risk, where competing risk generates basically dynamic selection. I think this is a main part and contribution of the paper. So here the idea is that factors that affect cognitive decline may also affect physical health, and this can then cause composition shifts over the age profile due to non-random mortality. For example, cigarette smoking causes mortality, and if that so because it causes mortality, if cognitive and physical health are positively correlated, then cross-sectional comparisons of smokers and non-smokers will understate the effect of smoking on cognition. So basically, the idea is that it relates really to this to the correlation that has really been important between smoking and health. So if we're looking again at smokers, and if smoking causes poor health, then the people that smoke more at some age will drop out of the sample. If this health then correlates with cognition, you also have selection on cognition. And so this means basically that certain types that you're not only selecting in your sample on health itself, but also on cognition. So this is what Michael Darden calls dynamic selection bias. And in this case, it may work in the opposite direction of the endogeneity bias that we first discussed, which reflects selection on the basis of education, selection of high cognitive individuals into higher education. So then the goal is to build a structural model of cognitive and general health that jointly captures heterogeneity, outcomes, and sample exits. It estimates the model using longitudinal data from the health and retirement study, and then it focuses on the effects of education and also cigarette smoking on cognitive health. So the motivation for education comes from cognitive reserve theory that we already mentioned. There's this observation that age profiles differs kind of in levels, and that is an indication of resiliency. And I think Michael also associates this with the endogeneity bias, which is again the selection of high cognitive individuals into higher levels of education. And so that this affects levels but not slopes, and also focuses on smoking because it's a mechanism that leads to dynamic selection. So basically, smoking is dynamically selected with health, and longevity is the idea. Smoking leads to poor health and selecting out of the sample. So this is a dynamic selection bias. So then Michael Darden argues that dynamic selection bias in the context of cognitive decline is as important as endogeneity bias. This argument I couldn't fully follow, but the one first argument is that cognitive health is important because it's policy relevant. Basically, that there are lots of Americans over the age of 45 report subjective cognitive decline, but they may understate its prevalence. This part I didn't fully understand, but in general, cognitive decline is just an important topic, and if we want to understand it, we need to think about dynamic selection on the basis of health. So, understanding the age profile of cognitive health and its determinants can also inform care decisions, financial planning, lifestyle modifications, etc. So thinking about cognitive decline and understanding it well is important. And we have this issue of dynamic selection. So So then a model is set up. It's a model of general health. So it's basically a utility maximization problem, or at least this is how it's motivated. And the actual implementation is somewhat different, but it's motivated by this setup. So we have a utility function of general health, HA, so physical health, cognitive health, CA, health investment, IA, and then some composite consumption good. So then there are constraints and laws of motion. We have a health equation. That's basically health in the next period is a function of basically the cognitive function health and some investment. And the investment actually in practice is smoking. So it's more like a disinvestment. Similar for basically the cognitive abilities. Depreciation in this model is kept general. It's not specified, which is also some of the critiques that I have, that it's not so clear what in the end is being done, what model is assumed. Okay, so, and then we have the equation here, which basically that the consumption good is kind of given when you have the investment given by this relationship, basically per period, but kind of constrained, some sort of permanent form of income, WA. Okay, so health depreciates in age, so it's increasingly costly to produce health. There are competing risks. Investments that maintain cognitive health may also have an effect on general health, on physical health. Mortality causes dynamic selection if general health and cognitive health are correlated with one another. Again, okay, we'll see that in a bit, because then this is then the here basically there's a switch to an indicator, and then the model starts representing more the potential outcomes framework. I don't fully understand how you arrived at this equation from the previous model, but it's kind of intuitive. So let's see what we have here. We have here the expectation of cognition, conditional on being alive, basically. This is health, above a certain health threshold, as in the Grossman model. So basically, your cognitive state, given that you're alive, so you're in the sample, and you're a smoker, minus the same thing, but for non-smokers. So basically, it's difference in means between smokers and non-smokers in the sample. So this is something that is observed. And then here we have kind of a level effect, and this is basically the object of interest. I don't know if I'm correct in this statement, but my understanding is this is basically the level effect that we're interested in for every age. So this is trying to get at we saw these profiles. We now want to correct these profiles for what they really are if you take into account mortality selection. So this is then a level effect here, and this is a dynamic selection effect. So this is the mortality selection that we've been talking about. So smoking then causes mortality. Then we have dynamic selective effects that increases with the correlation between cognition and health. So this is then a parameter that is important. Again, if we have mortality selection so people attrit from the sample based on health, then it matters. That matters for our how we correct for dynamic selection in cognition by this correlation between health, on which, if I'm understanding it right, the idea is that on health, physical health, the mortality selection takes place. But if there's a correlation, then you kind of have this effect also operating within your sample on cognition. So Yeah, so basically the dynamic selection problem then can be reduced to these three parameters: the cross-sectional standard deviation of cognitive health, which we also see here, the sigma c, and that parameter rho, which is the correlation between cognitive and physical health, and then the effect of each determinant, education and smoking, on sample exit. So the paper points out that while the focus is on dynamic selection, it also accounts for the endogenous nature of education and smoking. It does this by using that in a cohort of older adults, education is predetermined in a dynamic structural model. The conditions on both observed heterogeneity, so this is just controlling for a bunch of things, is my interpretation, and permanent unobserved heterogeneity, which is individual fixed effects. And then it also uses the local area cigarette taxes to basically as an instrument for smoking. So the model solution then yields dynamic smoking demand, health outcome, and selected mortality equations. These are estimated jointly using over 20 years of panel data from the health and retirement study. Basically jointly modeling sample exits, which is basically attrition from the panel, but also mortality, along with cognitive health. And this allows them to simulate counterfactual age profiles of cognitive decline for education and for smoking. A point is made that also this can be applied to other questions of interest. So this may be a more general method that is useful. It can be applied to the effects of health insurance on health. If those that are not insured are relatively healthy, and those that gain Medicare at age 65 will be relatively healthy. Maybe here this can also be basically this kind of this idea can be applied to that as well. And dynamic selection may also be relevant to the literature on the health effects of retirement. So the differences in the mean of that equation that we saw before can be from a cross-sectional comparison that's conditional on a dynamic process, and that's the important part of this. We have this selection on this dynamic process of cognition, but that is conditional on this dynamic process of health. And so researchers then that study, and I think I like this point, so this I think is why this work is significant. Is that researchers that use cross-sectional data can then solve the problem fully, because in this data there is no information on the path that led to a certain age. But longitudinal data can also be problematic, because in addition to dynamic selection that is generated by either attrition from the panel, which may also be a result of cognitive decline, right, or health, or death. And because this also basically generates a second source, which is referred to as the dynamic selection. Again, this dynamic selection is one of the main contributions here. So, and then if you have, with the exception of kind of life cycle longitudinal studies like the framing heart study, most longitudinal surveys will also suffer from an initial conditions problem. So the argument is maybe made that you need a more complex and more rich way of dealing with that. And this is what, by developing basically a structural model, and that's what's being done. So use of the health and retirement study, everybody will probably know this. The natural representative sample of seniors started in 1982, biennial interviews, rich information on health, healthcare, and socioeconomics. And we have about 11 waves of information, and the mean age in this sample is 66. So the health measures that are being used is a measure of cognitive health. This is basically the sum of the immediate and delayed word recall. So it runs from 0 to 20. Also an index of general health is basically the sum of chronic conditions up to a certain period, and a bunch of things are included: heart attack, blood pressure, etc. Here's a first sort of indication of this selection. We see here in the HRS smoking behavior, we see never smokers, former smokers, and current smokers. If we look at the word recall measure, then we see that 10 words are being recalled. But if you compare that with former and current smokers, of course, the never smokers should be healthier. But we see actually that that the never smokers do worse. But actually, they are 8 to 9 years older, suggesting basically mortality selection. So that's basically the issue here. So we saw the graph before on the age profile by education, that is being consistent with kind of cognitive reserve theory, that they're relatively parallel. And here we see very small effects on smoking, which probably reflects these selective exits. Now, we think that smoking is bad for health, but we see that never smokers, former smokers, and current smokers have similar life cycle profiles here. Of course, when you look at a current smoker, we're probably looking at a selective sample of very healthy individuals that survive, much more so than when you think about the non-smokers. So, all of this matters if there's a correlation between cognitive and physical health. And that's what we see here. This is one of the conditions basically for this dynamic selection to take place. So then here we see the fraction of the sample that is no longer responding to surveys. This can be because of attrition, mortality, and this is shown by age and education. And what we see basically is that we look at less than high school, the black line here, you see basically around age in the kind of 60s, 70s, early 70s, that there are many more of them that are not found in the data in the HRS compared to, let's say, college grads. So this is an indication of selective attrition. Here we see it this one was by high school, college grads. And we see this one here by never smoker, current smoker, former smoker. And so for never smokers, there's a quite dramatic, if you look here at 78, only 20% of the sample is no longer responding versus a current smoker where almost half of them are no longer responding. So significant attrition here. So then
5 minutes.
5 minutes? Oh, okay. I'll need to rush a bit. So, okay, so then there's the quasi-structural approach that Michael is using. He's jointly estimating equations for smoking, cognition, health, general health, mortality. Timing assumptions are motivated by the structural model, by the model formulation. He's allowing for permanent unobserved heterogeneity, correlated across equations, and throws it all into a maximum likelihood and estimates it. And then you can see here's then some of the main results, basically, that if you have the model with a single, the argument is made that you need a complex model, a real dynamic system. So the comparison here is with the single equation, dynamic single equation, and a real dynamic system. And we see basically that the effect of mortality selection increases with age here, it becomes worse, of course, at higher ages. That's the red line here, so the model seems to work. This was for smoking. So this one actually was for a difference between high school and high school grads. Here we see it for college and less than high school grads, also basically. And then I forgot, for some reason, to put the plot with smoking, but the plot with smoking shows actually very minimal differences, if I remember correctly. So here are a bunch of conclusions. Basically, dynamic selection is important, sort of bias. Cognitive decline depends in part on more general health. So that leads, the table concludes that education and smoking are more important risk protective factors for cognitive decline than previously thought. Here's some of my first kind of questions. Here we've seen a nice plot that shows this, but can this be quantified in some way? Can you think about expressing it and comparing it and understanding the significance of this? I don't know exactly how, but yeah. And also, I like your discussion that you really just need to do that. You conclude that constructional and panel studies also counter this the issue alone. So you're basically arguing for this more complex method to deal with it. I think this is a very high quality paper. It was not fully developed yet, but there was already enough in it to get a sense for what it would be. I think it's a very high, with potential for high impact. I think it's a paper that presents an issue that is quite intuitive. In some ways it's actually obvious, but I think it's often ignored and we don't really think about it very much when we're in our data sets and trying to establish kind of a relationship. So let's see, what else did I want to say? I think this is very important because the model is not fully developed. I think the model is fully developed, it's just not written yet on paper. So it was hard for me to understand. I think that it may help the reader, because if this is really important that we need to do this, then we need to have some sort of guidance for this paper to be successful, to make impact, that you give some sort of way of others to do this in other data sets, right? This is the barriers to using this paper is because there are barriers to building that model. The model formulation so far remains abstract. I think that is because the paper wasn't fully finished yet. Maybe we discussed this briefly. You thought about it, maybe doing this in a table. Maybe there's some sort of diagram, list of equations. Basically, the model is not yet developed because the equations are all using a general functional form. So understanding what the model is not clear from this from the current state of this paper. I was thinking, can you do some sort of robustness of the modeling exercise, exploring variations on the assumptions made or parameters used? I thought it was interesting that you had 7 different types. I'd like to understand it a bit more. You started doing that by exploring the mu 3 out of the 7, and I think you can do that maybe for the others. And all of my questions that I had from this is that I need more intuition to understand what the model is doing. The model is not really well described yet, and so this was hard to understand. It's basically, for me now, still a black box.
1 minute.
I think, I think we're there. So basically, this is my point here, that it's hard to understand the functional forms, things like that. And then I want to point out a little bit of self-promotion, sorry. With computer slides, I have this paper, Human Capital Formation, the Importance of Exogenous Longevity, where we developed a theory of human capital, health and longevity, and there are a lot of parallels between the work that you're doing, where we are having a sort of developing a theory, and you're doing this actually empirically. And there is selection in this model. So basically, we have longevity is endogenous. So it's to say mortality selection is in this model. It may provide a framework for you to use to motivate the analysis. Okay. Yeah, thank you.
Thank you, Titus. That was wonderful. I think you explained it really well. Thanks to the organizers for putting the paper in the program. So I mean, I have to apologize a little bit to Titus because he got the paper kind of in between presentations, and so it's definitely a work in progress. And I think you probably got that from the comments. I guess I'll just respond to a few things. This is kind of obvious in a lot of ways. I think a lot of economists do think about this, but it is something that you don't often see taken very seriously in empirical work. So a lot of us use panel data sets, a lot of us use the HRS, and oftentimes what we do is we'll say, okay, well, we have this kind of attrition problem, or we have this selective mortality problem. Let's create a balanced panel. The group of people within a subset of the data that we observed for the full 11 waves or something like that. And it just always struck me as that's kind of like a very limited approach, especially when we're thinking about a health intervention, right? Because mortality is is obviously one of the outcomes that you'd be concerned with. So Titus motivated this really well in his talk, but I was reading a lot about this cognitive reserve theory and dynamic cognitive reserve theory and cognitive decline, and it just struck me that the neuroscientists are they're using kind of the Grossman model, right? But they're not putting it in equations, and so it was just obvious that we could write something down and think about competing risk and endogeneity, these two central themes of kind of empirical applied economics, and maybe these profiles wouldn't be parallel anymore after we took those things into account. So I'm definitely not the first economist to think about selective truncation, these kind of issues, selection bias, dynamic selection bias. There are lots of terms for it. I'm not the first economist to think about that stuff, but I think this paper is novel in the sense that it's applying it to something that's very important and topical in the US right now, which is cognitive decline and Alzheimer's and related dementias. So just to get to a couple of his points, yeah, so I apologize that wasn't clear, but Lauren Nicholas has these great papers where she thinks about the fact that cognitive there's evidence that when you link credit scores to some of these health measures, people are making really bad financial decisions well before a formal diagnosis of Alzheimer's. And so we don't really know what the inputs to this function are. We're not doing a very good job, and we can't fully diagnose Alzheimer's until death. So a paper like this where we're thinking about the determinants of this function, I think is timely. Let's see, what else? Yeah, so this issue of health depreciation is one that I think the Grossman model gets wrong, and Allman and Curry point that out quite forcefully by saying that if there are differences in neonatal health or something like that, fetal health, if you assume an exponential discount rate, then those things are going to converge over the course of 30 or 40 years. So I keep it general in the theoretical model, and then the quasi-structural application is very much a reduced form. In the case of cognitive health, just an OLS regression that's estimated simultaneously with other characteristics, with other outcomes. Let's see, what else? Yeah, so the empirical application, again, Titus is right, it's not fully explained. I think there's definitely some assumed knowledge that probably should be a little bit more fleshed out there. But it's a correlated random effects model. So it's like an Arellano model where you have the error structure across the equations are correlated. And I've done some of the robustness that he's talking about, where you think about maybe different specifications of that error structure. Right now, it's just a kind of a permanent unobserved type. But I've done some stuff where I do varying unobserved heterogeneity and some new dynamic unobserved heterogeneity, where you have a state variable that's dynamic but unobserved. And interestingly, in that including that stuff in principle should change some of the coefficients, but it doesn't really change some of the main conclusions of the paper. And then just one thing I'd like to point out here, if I could.
5 minutes.
Thank you. Yeah, here. So what I think is just really interesting about the results, the black line is essentially just like cross-sectional comparisons. The blue line is a single dynamic equation for cognitive health. And these are the gap between college-educated and less than high school. Okay? And so what you see from the black line and the blue line, it's not fully, these aren't flat, but they're relatively flat. And then this red line is my system of equations where I take into account this dynamic selection, and you can see that it's clearly not parallel, especially at relatively young ages. It's growing, this effect of the gap between college-educated and less than high school is growing considerably. This is the sum of word recall coefficient, and it goes from 0.5 words up to 2.5 words. And then it becomes parallel at about age 70 onwards. And so this is the opposite of what cognitive reserve theory says, right? This picture that you saw with the parallel lines, those were just cross-sectional comparisons. But this model is saying that, oh yeah, well, when this selectivity really ramps up, where we see like low-educated people really dropping from panel surveys because of attrition or because of mortality, you see a very non-parallel path to the differences in cognitive health. And so I think I'm still working on this, and I'd love to hear your thoughts, but I think that's policy relevant. This is also consistent with the research I've done on smoking, where smoking really starts to take a huge bite after age 50, between age 50 and age 70. That's where you're having a huge loss of the sample. So yeah, I'll open it for questions.
So I've got a few priors that I'll throw out, and I want you to either like just confirm or tell me I'm wrong. So one, I have a prior that almost no one stops smoking after they're 60 if they've been smoking up until they're 60.
People do. People definitely do.
But what does that mean? Like conditional on smoking while I'm 60?
No, so smoking is actually, so there's one important difference between education and smoking, and that is that you can quit smoking, right? And so that means that it's not just mortality selection that matters here. And Frank Sloan was showing this along 20 years ago, but I kind of followed in his footsteps in some sense. But like smoking and health is dynamic, right? So you have two forms of selection now with smoking, but you only have one with kind of mortality selection with education. But with smoking, you have a lot of people that have a major health shock and they quit. Right? So then what you are observing when you look at smokers versus non-smokers are all of the smokers who have not died, but also haven't had that major health shock yet that convinces them to quit. Mm-hmm. So the primary reason for people quitting in their 50s and 60s is major health shocks that don't kill them.
Okay. So that like leads to, okay, so that first prior maybe is a little bit wrong. Second prior, I think you just confirmed, if I quit smoking after 50 and 60,
yeah.
It's not about taxes, it's about something else. So my prior is that like, that's probably not a very good exclusion restriction, and a suggested potentially better exclusion restriction might be something like my spouse has a major health shock.
Yeah, so Frank Sloan he's looked at that too, and that would be a very weak instrument. That would be a weak. But on this, I'm with you on the price elasticity of demand being relatively small for the elderly. But there's a lot of evidence of persistence in these things. So one of the robustness things that's not in the paper, and that's I should apologize again to Titus, but like you can look at like cigarette taxes, tobacco control policies generally when people were in their teens and 20s, and there are differences when they're in their 50s and 60s. So those, because you've got an exogenous difference in prices when you're young. Some people get addicted, other people's so you can see we could do stuff like that.
Okay, so I won't call that over two, I'll call that like half for two.
Okay.
Third one, and this is one that I know you know something about because you have another paper that looks at for someone who's been a smoker, when they quit smoking, how much that increases their lifespan.
Right.
And I wonder in that prior paper, did you look at quitting at different points in the lifespan? Because I also have this prior that like, if I quit smoking when I'm 45, that probably has a much bigger impact on my expected length of life than if I quit smoking when I'm like 65.
That's right. So basically, this is where I'm in agreement with the epidemiology literature. If you quit up to age 50, you don't see big differences in longevity. But what's interesting, and it's not like
wait, if you quit after age 50,
if you quit smoking up to age 50, so sometime before age 50, right? Yeah, but what's interesting is that the mean is one thing, but like if you smoke up to age 45 and then you quit, the variance of outcomes for those people is higher. Yeah, but that's like a little nuance that's not typically thought about.
Okay, so I've like taken a bunch of time where all this is going. I I wonder if you could save yourself some hassle in estimation and ultimately sacrifice almost nothing by just treating smoking as an initial condition and letting it affect your type probability. Like my guess is that you would sketch out effectively the same pattern. Like, given that even though some people do quit smoking, it's not a ton, and quitting smoking late doesn't have a huge impact on your health, that if you just treated it as an initial condition, you would have fewer parameters to estimate. My guess is you'd have something that looks the same.
I certainly could do that. I mean, I think that would be interesting. It's not that quitting after 50 has no health effect. I think, and in fact, from a policy perspective, that's kind of, it's still very relevant to get the 55, 60-year-olds.
It's also the case though, if the pictures look the same,
Yeah.
as a referee, like I can't pick at your exclusion restriction anymore because you don't need one.
Okay, fair enough. Yeah, that's good.
Any? Here. Matt, here, sorry.
I can hassle you more in great detail about this over dinner.
We have 5 minutes, so don't worry.
Okay.
But don't take it all.
No. So I think about how you're gonna about selling this, and I think for a policy contribution, is it possible for you to essentially bootstrap the heck out of it and generate a whole bunch of replicate individuals, right?
Yeah.
And then forward simulate the time path of cognitive decline, turn off various aspects of it, and see how much the mortality changes. See how these mortality effects and dynamic selection effects are going to affect the number of people in 10 years we think are going to need long-term care for cognitive limitations. So from a policy hook, right, you think about this from a capacity planning perspective. That if you believe the balanced panel and cross-sectional stuff, you're going to have one share of the population that we think, but that.
Yeah, I mean, I think that's I could definitely go in that direction, and I will. That's a good point. One of the things that I think is just really interesting about this is that, like, if you know, life expectancy in the United States is going down, right? Which might give us the suggestion that we're actually like making progress on Alzheimer's disease, right? But it's not actually true. It's because these people are just dying, right? And so, like, the opposite, if you know, if we can increase life expectancy in some ways, right, we might think that we have this horrible epidemic of Alzheimer's disease, when in fact it's just people are living longer and the brain pathology is developing, you know. So so I think you're right.
But yeah, that should be a nice hook for you.
Yeah, great.
We have time for one more question.
just ask
Anybody?
one clarifying
Yeah,
question?
Yeah,
Yeah,
take the
Michael,
microphone part.
So are you distinguishing between mortality and survey attrition
Yes.
every time? Yes, so
They're separate equations.
they're separate
Yeah, they're
equations.
separate equations.
So I think, sort of going back to what Matt said, what the question in my mind was that they're very different policy recommend. So attrition matters for the pictures,
Yeah.
and it doesn't matter what kind of attrition it is. Basically, they're out of the sample, so they're going to give you biased results. Yes,
Right.
but if you die quickly, then you take your Alzheimer's with you, and sort of you're no longer a policy problem, basically, right? It's the ones who live, whether or not they're in the survey, is irrelevant for the policy question,
You're right.
right?
Right.
Okay, that I was just.
Yeah, and actually, that's a good point. I
like
mean,
to
I
keep it
actually.
simple. They're gone.
Die quickly and take your Alzheimer's with
Yeah,
you.
well, there is actually more time for one question, Ed. Yeah. Will be the last question, and then
You guys gave me a new title.
you can, yeah, if you die quickly, you're not a policy problem. Okay, Ed, question, thank you.
It's kind of like Ebenezer Scrooge, talking about poor people in London in the 1800s. Could you just interpret the red line? So say at age 80,
Yeah.
what does a 2.5 word difference mean? What exactly are you conditioning on, and who are you comparing to that?
Yeah, so this is for at age 80, it would be about 2.5 words between, that's the average difference. It's the difference in the difference in means that comes out of the structural model between college-educated people and less than high school.
Can you say that without the word structural model?
Sure, yeah. So, I mean, it's conditional on, it's conditional on all the X's that are in there, so different types of health. gender, age, race. There are a few other things I forget.
Conditional on survival.
Yeah,
And
conditional,
that's-
yeah, it could conditional on
It is
survival.
conditional
right.
on survival.
Yeah,
It is
so if you're
conditional?
netting out that, right, so it's like, the way to think about the way I think about the system of equations is it's like, this is the structural equation of interest, right? But it's estimated jointly with a mortality and attrition process, so in a sense, I'm holding that fixed. So like, I'm holding the probability that you get to this point fixed. And this was, and you get very different answers when you do that relative to not doing that, which is the blue line.
So is that sort of reweighting the fraction of people who make it to each age?
Yeah, I think so. I mean, this is related to inverse probability weighting.
Okay.
Right? So that's the way you would do it in a very atheoretical way, right? There's a probability of survival at each age, and you can construct a hazard up to that point, right? And then you construct a weight, but what's different here is that inverse probability weight from Woolridge and others, it does not take into account the rho, which is the correlation between general health and cognitive health. And so I guess, thank you for clarifying that, because this has actually been really, that's the big difference here. And I've done this plot with the IPW weights, it's essentially.
Okay, that was the last question. We can move this to dinner. Yeah, if we do one more
Very
question,
short
I'll stay here.
Can this be applied to a panel where there's multiple exits and enters?
There is multiple exit.
Yeah, there are multiple forms of exit. Now, different entry times is a different left censoring kind of problem. That's like an initial conditions problem, I guess. So I'd have to think about it. Yeah, you could.
Well, a round of applause for